discuss electric motors. That is the second one of actuators. In the previous class we discussed hydraulic and pneumatic actuators in connection with the classification, and today we are going to discuss electric motor. Actually, electric motor have different sections or different types of motors. That is DC servo motor, stepper motor and AC servo motor. In today's class we are going to discuss DC servo motor. Okay, it is the most commonly used actuator. Actually, electric motors are the most commonly actuator. Of course, stepper motor are the most important because of its excellent controllability with the minimum maintenance. We go for electric motors compared to the hydraulic and pneumatic actuators. Okay, let's see what is happening in DC servo motor. In DC servo motor, the main components are a rotor and a stator. A rotor means the rotatory part, and the stationary part is stator. Actually, rotor includes an armature and a commutator assembly, and the stator has that includes a permanent magnet and a brush assembly. Okay, the principle behind DC servo motor is that when the current flows through the winding of the armature, that set up a magnetic field opposing to the field set by the magnets. So in the rotor part we have some armature and winding assembly, and in the stationary part we have permanent magnets. When we apply an electric current to the winding or to the armature, it creates a magnetic field which opposite to the field of permanent magnet. So this will produce a torque on that motor. What is torque? That is the rotatory active acceleration, revolutionary acceleration. Okay. So a rotor, as the rotor rotates, the brush and the commutator assembly switch the current to the armature continuously. If it placed like this, if the rotor rotates, the brush will connected like this, and it rotates, it will get continuous current, or it will supply continuous current to the armature, so that the field remains opposed to the magnets. Always the field to be opposed to the magnets, that is the permanent magnet. Okay, so I already said that while rotating this armature we get a torque. That torque can be defined as, or can be write as Tm of T is equal to Km IA of T, where torque of the motor is represented as Tm of T, and that is equal to Km IA of T. Kia means current flowing through the armature. Ia means current flowing through the armature, and then Km is motor torque constant. Okay. So another effect in DC servo motor is its back EMF. When the rotor rotates, there is chance of generation of an voltage back to the stator. Armature, back to the armature, and the spinning of the armature in the presence of a magnetic field produces a voltage. Usually we know that a changing magnetic field creates a electric field, or a changing electric field creates a magnetic field. Here if the armature rotates, the magnetic field will change, and a chance of developing a voltage in the armature, and that armature voltage is called that particular voltage is called back EMF, and that voltage is proportional to the angular velocity of the rotor. Okay, and it is represented as EB of T. It is equal to KB omega Kb is the voltage constant, and omega is the angular velocity. So Eb of t is equal to Kb omega t. As the back EMF is equal to Kb of omega t, the voltage must be subtracted from the input voltage of the armature. So the total actual armature current becomes Ia is equal to, armature current is equal to Vin minus Eb, where Vin is the voltage applied to the motor minus Eb. Eb means that is the back EMF divided by R0. That is the resistance of the armature. And we can see the diagram of or block diagram of a DC servo motor. This you can see the input voltage applied to the section and to the armature voltage creates an acceleration, that is a torque there, and this torque creates an acceleration, and the generation of back EMF will feed back into the system, thereby we get a constant or steady rotation at the output of the motor or the rotor part of the motor. So this what happens in DC servo motor. In the rotor part we have an armature and a commutator assembly, and in the stator part we have a permanent magnet assembly. By applying a voltage to the armature, it creates an opposite magnetic field which is opposite to the permanent magnetic field. This will create a torque. Okay, so that's the principle behind an electric